Welcome to the Robotics Challenge 2025. We are a mixed team of the Technology Transfer Center Kitzing and the Center for Robotics of the Technical University of Applied Sciences Würzburg-Schweinfurt. Our team consists of bachelor, master and PhD students from the Robotics and Mechanical Engineering department. Our hardware setup consists of a UR5E cobot with a Robot IQ gripper with customized gripper fingers. We use an automatic tool changing system to switch to the cable tie gun. We use two cameras for cable orientation detection and a vibration motor for cable insertion optimization, coming to the total of 40,670 euros. We use a sense plan act architecture. For sensing, we use two cameras, one for the cable bending detection and one for the cable pitch detection. Additionally, we use the cobot's force sensor for getting force feedback while inserting the cables. For planning, we created a task scheduler that alternates between the tasks. And for act, we use the cobot along with our customized gripper solution and the automatic clip gun. All our software modules communicate with the hardware using the ROS framework. Diving deeper into the sensing module, the first task after gripping the cables is determining the pitch and the bending of the cables. For the pitch, we use key point detection using YOLO pose, which was trained on the dataset we created. Then we calculate the gradient of the line shown in the figure. And last but not least, calculate the correction angle to get the pitch difference that the robot should correct. Our solution is capable of detecting and adjusting up to 90 degrees of correction using this concept. The second step is the calculation of the bending, where we use the YOLO segmentation model. We segment the cables and then approximate its contours to 4 points connected using straight lines, and then calculate the bending angle correction, which is the angle between the blue and the red line in the right figure. We can now use the cobot to correct the pitch and the bending before inserting the cables into the connector. For the binding of the clips, we use the grip auto connector, which is an automatic tool changer. We change the gripper with the automatic clip gun for the clipping process. The clip gun is connected to the robot control box and fired at the desired locations. As time is a very important aspect in the automatic assembly of the wire harness, our initial gripper design concept was to pick the whole cable as shown in the right figure. We designed the gripper fingers in a way that they have specific grooves to securely grip the different cable types. With this design concept, we save time in cable picking by picking 2 terminals at once and move directly to the insertion process. However, due to inaccuracies in 3D printing, we had some problems integrating this design into the full run. In the future, we want to switch to metal fingers to avoid these problems. For the cable insertion in the full run, we use the force feedback of the cobot. Additionally to that, we use a vibration motor that uses linear vibrations to attract the cables to move into the connectors automatically. This eliminates the need for adding force feedback insertion, which takes more time. However, the solution isn't 100% mature, so we couldn't rely on it in the full run, as sometimes the cables aren't fully inserted, which causes problems closing the connectors. The vibration solution saves 15 seconds compared to the force feedback for every cable.